Chapter 13, we continue with probability. Now we go a little bit deeper. Last time we talked about what? Probability is a long-term trend, right? We talk about sample space. We talk about disjoint, or sometimes people call it mutually exclusive events. And we talk about random variable. How many types of random variable do we have? 2, right? Discrete random variable or continuous random variable. All right, recall disjoint. Disjoint or mutually exclusive events. I have 2 events called event A and event B. If they are mutually exclusive or disjoint, if they do not contain any same outcomes, right? Because there's no intersection. So if you're gonna draw in Venn diagram, there are 2 balls separately, no intersection. Do you guys remember the additional rule for disjoint event P of A or B? P of A or B. Instead of writing or, I use the upper U for union, right? P of A union B is equal to P of A plus P of B. Pretty straightforward, right? I want a probability of the union of the 2 balls. Well, probability of the first ball adds to probability of the second ball. Pretty straightforward. Let me ask you a question. So this is called additional rule. For disjoint. Later, you're gonna see a more general additional rule when the 2 balls intersect, right? 2 circles intersect. What about P of A and B? By the way, I can rewrite P of A and B as P of A intersection B. Right? It's or it's the same thing, right? Either you can use English or you can use notation. What about P of A and B? What is probability of A and B? Is there any probability of A and B? No, right? So 0, right? Or written as. So 0, right? So 0. There's no intersection. And this thing called union, and this thing called intersection. Oops. So that's mutually exclusive event, right? It's pretty straightforward. But now, what if 2 circles, they kind of intersect each other? Now it get a bit more involved, right? P of A or B no longer P of A plus P of B. So now, if you look at the picture, I know the P of A and B. Can I use this instead of the right end? Is that okay for you guys? Just and B is equal to, well, I know it's something, some probability, but it's not 0, right? It's not 0. It's no longer 0. And then furthermore, P of, let me write in blue for M in blue. Furthermore, I know that P of A or B, the union P of A union B, is equal to P of A plus P of B, but then you have to subtract what? So you shade the first circle and you shade the second circle. What happened in the middle part? How many times you shade in the middle part? Twice, right? So you got to subtract the extra shade that you did, right? So it's minus to P of A and B. So this is additional rule. This additional rule. In general, A and B not always disjoint. Like actually, most of the time it's not disjoint. If I don't say disjoint on the exam, do not assume they disjoint. Okay. If I don't say anything, that means they probably looking like this. So the reason, again, let me explain. The reason we subtract P of A intersection B because we're gonna take out that double counted part, right? We count it twice. Let me ask you something. Maybe let me use purple for this color. For that. Blue for that. And then maybe like a burnt orange. That one. And then black for the last part. Let me ask you something. I have P of A union B. This one right here is a probability of where A and B's are disjoint. And I wanna ask you, which one have a larger probability? The one that union is disjoint case or the one with the formula above? Which one have a bigger probability? That's disjoint. Which inequality you think is gonna face? You think the probability of A union B for the disjoint like that, is it bigger or smaller than the probability of the union of a not disjoint events? Pretty simple, actually. Okay. Let me write again. Here is disjoint. And here is not disjoint. This one have a bigger union. The disjoint one, right? Definitely. The areas, in terms of area, is bigger, right? Than the one that have intersect each other. So definitely disjoint is bigger. A bigger probability. In terms of union wise. You add the area of two separate circles as opposed to you add in the areas of the circle that intersect each other. You have less area. An area is probability. And it makes sense. Actually, for the additional rule for the disjoint, you can write like this: P of A plus P of B minus P of A intersection B. But we talk about P of A intersection B is 0, right? So mine is 0, just we don't write it, right? That's why for disjoint, we only care about the first two. So we can remove that. We remove counting. So and that is the rule right there. In general, that's your additional rule. On the exam, if I don't say disjoint, you always assume the two events looking like that. They kind of intersect. Let's try this one. During the first week of 2019, the Pew Research Center tracked the type of English language YouTube video posted. Let A be the event that the video posted involved games of some sort, including sports. B be the event the video posted involved hobby, skills, including sports. The Pew Research Center, which is a very reputable center here, find that the probability of P of A is 30%, probability of B is 13%, and the probability of the intersection is 34%. Is it a joint event? No, right? Because why you know that it's not disjoint? Why you know that it's not disjoint? intersection. It's actually, I'm sorry, I said intersection. My bad. It wasn't intersection. It's union. If it was disjoint, the union should be equal to what? 1, right? You add them together, equal to. So I know that this is not disjoint. I'm gonna draw 2 event here in circles. Say event A and then event B. It doesn't matter the size really. All right, let's highlight the portion of certain event. Make a Venn diagram showing the event A and B. A and B. A and B, that will be that tiny little region intersection right here, right? That's A and B. So that's right there, that's A and B, or A intersection B. What about A and not B? What A and not B mean? A and mean intersection, not B mean B complement, right? So they want you to find the intersection of A and not the ball B. Well, intersection of A is A itself and not B. So you do not want to highlight the yellow part, right? Because that yellow part is part of B. So here's A intersection not B. So far so good. Why don't you guys do the next one? B and not A. Actually, you write it down and give it to me the answer. Yeah, this one. I want you to do this one. B and not A. Let me give you a little hint. B and not A mean B intersection A complement. Write out your answer. Give it to me. Yeah. That'll be your bonus. For people who wasn't here last time, I have a new strategy that I give people bonus point when, say for example, right now you give you the answer of B intersection not A. If it's correct, I'll give you a point on your exam. So write out your answer on the piece of paper with your name on it. And it's all volunteer. If you don't want bonus point, that's fine. Hmm? Yeah, you can use this. Okay, shade the region for me. Very good, very good. So that means I know you understand what I'm talking about. Okay, very good. The in green, I always put the question in green, dark green. So find the probability of, find the region that B intersection A complement. Yeah, just. More work for me. I said, thank you. Very good, very good. Very good. I got more people kind of right. By the way, I only keep the correct answer. Okay, if the wrong answer, I don't keep it. So. Is that everybody? Is that it? No. Shade it for me. Shade it.
All right.
Good, thank you. 2 more minutes. 2 more minutes.